Hi guys, so what we're going to be talking about in this lecture is tangent lines and instantaneous velocity. And so what this is a continuation of what we did last time, which was secant lines, and we didn't have instantaneous velocity, but we had average rate of change, which we could have also called that average velocity. So this is very, very closely related to the previous lecture. So let's talk about it a little bit. So let's just draw some pictures of what a secant line and a tangent line are, and then we'll give some definitions. So let's see. Secant versus tangent line. Okay, so we need to draw a function. I'm going to draw the picture here. That's just a function, so we'll call this y equals f of x. I need to put a point on here. I'm going to put the point right here. I'm going to call that a, and I'm going to put another point on here. I'm going to put it up here, and I'm going to call that a plus h. Now we did that a little bit last time, but not too much, where we called it a plus h. We're going to do that more this time. All right, so I'm going to duplicate this and move it over here. So I've got, just two of the same graphs here. All right. Now, I wonder, yeah, I can. There we go. So I've got two of the same graphs here. Now we know what a secant line is. A secant line is a line that goes through 2 points on the graph. So like, I'm gonna make it straight, like that. Just pretend that that goes through them both. Okay, that's a secant line. And so, let's see. We know that the slope of the secant line is, what do we know it is? It's m secant, and it was y2 minus y1 over x2 minus x1, but with the points labeled the way they are, that works out to this formula. Okay? But anyway, the point is that it's the slope between 2 points on the graph. Now, a tangent line's a little bit different. A tangent line, you'll notice I only have 1 point on the graph because I deleted the others. And so what a tangent line is it is a line that just goes through that one single point and just touches the graph. I'm going to draw that a little better, so I'm going to delete it actually. See if I can draw it a little better. That's erasing. Yeah, that's close enough. Okay. No, it isn't actually. I changed my mind again. I'm deleting it again. Okay, third time's the charm. This is going to work. I feel it. Yeah, that's better. That's what that should look like. Okay, so this is a tangent line. And so a tangent line versus a secant line only goes through 1 point on the graph. Okay, so I say it only goes through 1 point on the graph, but like if we extend this line this way, right, it actually does intersect down there, but that doesn't matter. When we talk about it, we don't care about that kind of intersection. The way that we got the tangent line is right here, where it just touches at that 1 point, and way over here, who cares? Okay, that's not what we're talking about. So that's a tangent line. Okay, now you might say like, well, how are we going to get that line, right? So the tangent line, goes through only 1 point. Only with an asterisk, 1 point on the graph. And hopefully what you can see there is that the slope of the tangent line, like basically the slope of the line matches the slope of the curve right there. So the tangent line at a comma f of a has a slope, has the same slope as the slope of the curve. At that point. Okay? So that is a tangent line. Now, where do we get one? How do we produce this slope, right? Because I wrote a formula for the secant line, but I didn't write a formula for the tangent line yet, right? And so the idea is this. If I draw a couple of pictures here, I'm gonna erase that, draw a curve. Come on, make that level. Make it level. Okay, there we go. And I kind of actually want it a little more curvy than that. Yeah, that'll work. So let's say we want a tangent line right here. Okay? What we're going to do, I'm going to duplicate this, duplicate it, put it there. And I think I'm going to even duplicate it one more time. Duplicate it, and I'm going to put it there. Okay, so got the same graph on here 3 times. The last 2 are kind of overlapping, but that's okay. So here's the idea. We're going to call this A. Okay, so that's at x equals A. Now, if I draw secant lines on here, secant, not tangent, with another point, I can put my like A plus H over here. Okay, and then I can draw a secant line through those, right? So this is a secant, right? But what if I just put the points a little bit closer together? What if I just slide this point over a little bit? So now instead of A plus H being, the points being spaced the way they are, what if I just point that, right there, right next to the A? Then I get a different secant line, right? But what if I slide it over a little more? What if I slide that point over to where the 2 points are overlapping? So I got that, and I got an A plus H. And then what if I put A and A plus H in exactly the same spot? That's how I get the tangent line. All right? So do you see what we're doing? We're just starting with 2 points and drawing a secant line, and then we're just sliding that 1 point over until it overlaps with the other point. And when you do that, it stops being a tangent line and it stops being a secant line and becomes the tangent line. All right? And that is what a tangent line is. Okay? Oh, by the way, so if you keep hearing loud like pops and bangs, it's the 4th of July, so that's just outside. So sorry about that. Can't do anything about it. Anyway. All right, so secant line, tangent line. That's what we got there. Now, how are we going to do it? Well, formally, we're going to do it with a limit, but we're going to do that in the next section. We're not going to do it now. Okay, so I can write it. So formally, the slope of the tangent line at a comma f of a, because it's at a point, right, is, and so what you do is you take the slope of the secant line, which you can get various ways. I'll write it this way. This was one of our forms for the slope of the slope of the secant line. So this is a secant, and all you do is you take a limit as h goes to 0, right? Because the space here between these 2 points is h. The space here is h. The space here is h, right? So if h gets smaller and smaller and smaller, then the secant line turns into the tangent line, and this is the formula that does it. Okay, but we're not going to do that in this section. We're going to do that in the next section. In this section, however, we're just going to basically just guess the answer for what those are. Okay, now what do I even mean by that? How are we going to guess the answer? Basically, what we're going to do is this. Have a notification. How do I make it go away? All right, I did. It went away. So how do we do it? So I'll show you. So here's an example. Estimate the, what are we calling it? Slope of the tangent line. Tangent line to f of x equals negative x squared plus 2x plus 1 at x equals 2. And they'll even tell you how to do it. They'll say using the average rate of change over smaller, they say successively smaller intervals. All right. Okay, what's that mean? Well, first of all, make sure you know where we're doing this. X equals 2. Okay, and so what you do is, I'm not going to draw this actual curve because it's not worth our time to make that, you know, that graph exactly right. Let's just say it looks like this. Oh, I can do a little better than that. Okay. Let's just say it looks like this. I know it's a parabola and it opens down, but I don't really know anything else about it. So I'm going to put the point right here. Now, again, I just drew this with at 2, it has a negative slope. I have no idea if it has a negative slope at 2, okay? This is just a random guess at, you know, a function. So we want to try to find the tangent line here. So what you do is, like, you start out with, like, let's say that that's 2, and what if we just put like 2.5 here, right? Then there'd be like a point down here. So you start out with that. You could do like average rate over x equals 2 to x equals like 2.5, right? But then we need to take a smaller interval. So after we do that, I'm going to leave some space. We're going to do the average rate over, let's say, x equals 2 to x equals 2.1, right? That's going to be a much smaller interval. So like if we do this first one, let's do it. Remember, it's a slope of a secant line, m secant. We know it's f of b minus f of a over b minus a, right? So you have to put these into your function, see what you get. I keep doing the same thing. I want to make a small one. F of 2.5 minus f of 2 over 2.5 minus 2. Notice that I'm switching back to my old formula for this. The one with a plus h is not so useful here. But it's the same thing, so we can do it either way. All right, so what do you have to do? Well, you're going to have to plug the 2.5 into this function here. All right, so I didn't really leave myself space to do that. Did I? No, I didn't. But, you know, so you're going to have to put in a 2.5 into your function. So like negative 2.5 squared plus 2.5 plus 1, and then minus, and, you know, I'm out of room. I guess I can try to make myself have enough room here. I don't think that's going to work, though. Yeah, no, see, it grabs too much. Maybe I can be more careful. I'll try one more time to move that, and let's hope for the best. I have no idea what it just did, but that was not what I wanted. Okay, got it. Okay, good enough. So then you got to put a 2 in there. So you put a 2 in your function, you got negative 2 squared plus 2 times 2, I'll just write that as 4, plus 1 over, again, 2.5 minus 2 is 0.5, right? And you just have to evaluate that, and you have to get a number there. So I'm going to just grab the calculator. Actually, no, I'm not. I'm just going to go to a computer. Negative 2.5 squared, 2.5, I'm going to have to write this down, sorry. Negative x squared plus 2x plus 1. Okay, got it. So, come back here. What do we have? Negative 2.5 squared plus 2 times 2.5 plus 1. Okay, and that looks like that's going to be negative 1/4, or negative 0.25. Now we're also going to need this with a 2 plugged in. So let me fix that. Oh, wait. No, that's right. Sorry. Negative 2. Put the cursor there. Come on. Okay, got it. Negative 2 to the 2 minus 2 times 2 plus 1, and that's 4. I said that's 4, but that's not. That's so the final result there is 1. So we got a 1. So what we actually have then, I believe, in that entire fraction is negative 0.25 minus 1, and then parentheses, oops, parentheses, and that was supposed to be negative, right? Negative over 0.5. And we get negative 2.5. Negative 2.5. Okay. Hopefully that's right. If it's not right, who cares? Because we're going to be doing this a few times in a row. All right. And what that is supposed to be is it's supposed to be, the slope between these 2 points. Although, again, this graph was just for like illustrative purposes. It's not like a very good graph. Is what it is. All right. Now let's do the next one. Average rate between these 2 points. So you're just going to start over, right? It's going to be m secant is f of 2.1 minus f of 2 over 2.1 minus 2. So bottom we got 0.1, top we got some stuff. Some things you can cheat at, right? F of 2 is the same thing it was last time. So it's going to be 1, and you got to plug a 2.1 in there. So you have negative 2.1 squared plus 2.1 plus 1. Head back over here. Move this over. What do we have? We have negative 2.1 squared plus 2 times 2.1 plus 1. 0.79. Okay. 0.79. Let's just do the whole thing here. So that was the first thing. And we know we have minus 1. That's the second thing. And then we know we have over 0.1 in the denominator, and we're going to get negative 2.1 for our answer. So we go back to notability, negative 2.1. Okay, so that's what we get there. Try it again. So that what that is we did like the first one and we got negative 2.5, right? Well, then we took this point from 2.5 here, and we just moved it really close to the 2. So we got like a point here now, and then we drew that line, and that has a different slope. So we got the 2 points closer together here, and then we're going to do it again. So we're going to do, let's say, average rate over x equals 2 to, let's say, x equals 2.01. So m secant f of 2.01 minus f of 2 over 2.01 minus 2. That's going to be negative 2.01 squared plus 2.01 plus 1 minus 1 over 0.01. So again, back over here, what do we have to change? I think we just have to add the O's here, right? Okay, what do we get? Negative 0, wait, I had to change this one too. Okay, negative 2.00999, 2.00999. All right, there you go. Now that should be enough. Let's look at our answers. So the interval, put here, and let's put the slope, or, rate of change. So the interval, when we did 2 to 2.5, we got negative 2.5. When we did 2 to 2.1, we got negative 2.1. When we did 2 to 2.01, we got negative 2.00999. Now, the idea is, if you just imagine that we continue this on forever, dot, 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 let's say we just went 2 to 2. Now, you can't really do it 2 to 2, but imagine, right? If you did that, what answer would we get right here? And hopefully you can see that what's happening is these are getting closer to negative 2. So if you wanted to guess at the result that would go right here, you would guess negative 2. So this isn't something that we calculated right here, this is our guess. Guess we would get negative 2. Okay, and that's how you get this kind of answer here. Okay, just smaller and smaller intervals. And the homework is basically doing this, several times, and getting some kind of answer there. I'm going to find one more, and then we're going to switch problem types and do a different type of problem. Come on, give me the same type. That's all I want. All right, so here's another one. So same type of problem, and we're just going to hope that we're better at it now. Okay, I don't like how laggy this is, so I'm going to close it and open it again. All right, so let's try this again. So again, we're going to find instantaneous velocity. Oh, actually I didn't use that word last time. But we're going to find instantaneous velocity, which is the same thing as instantaneous rate of change, which, what did I call it here? Velocity. But velocity slash rate of change, same thing. Right? And we want to find of what function? Another quadratic, x squared plus 2 at x equals minus 1. All right, and we can even be more organized this time and maybe do a better job here. I don't know how much space I'll need. But let's just think about the interval that we might use here for doing this. So if we're going to evaluate this from or at -1, we can go from, let's say, -1 to, what do we want to use? It doesn't matter what we use. So like, let's say -0.9. That'll work. And after we do that, we're going to need a closer interval. So let's maybe do -1 to -0.99. And then maybe let's do a third, 999. But hopefully we're going to know the answer after 2, and we won't even need to do the third. We'll just be able to have our like -1 to -1 guess. Okay? So that's how we do this. Now, what's the formula that we're using, right? Remember, we're going to be doing f of b minus f of a over b minus a. That's it. So for this one, right, it's going to be f of -0.9 minus f of -1 over -0.9 minus 0.1, which is positive 0.1 in the denominator if you add that up, and in the numerator we're going to have -0.9 squared, parentheses on it this time, plus 2 minus, and then we're going to plug in -1 here, -1 parentheses squared plus 2, which is going to be, let's see, the second one I think we can probably work out by hand here. -1 squared is 1, 1 plus 2 is 3, so 3. The other one is going to be 0.9 squared plus 2. Let's head over here. It's like this, -0.9 squared plus 2. What do we get? 2.81. So, what do we get? 2.81. So you work this out. We're going to get 2.81 minus 3, which is going to be negative 0.19 over 0.1, which is -1.9. So that's what we get. All right, now we're going to do it again. So we're going to have f of -0.99 minus f of -1 over -0.99 minus -1. That is going to be 0.01 in the denominator. Second term is going to end up 3 again. And we're going to have -0.99 squared plus 2. So basically we just need 0.99 squared. 2.9801. 2.9801. I went back to the same thing. 2.9801 minus 3 over 0.01. All right, let's just do it on a calculator. All right, what are we doing? Minus 3, close parentheses, close the parentheses. That's the entire numerator, and we're supposed to go over 0.01. Negative 1.99. All right, so you want to hazard a guess at what's going to happen down here? We can do the third one. What do you think it's... No, I want a squiggly. I want a squiggly. What do you think it would be if we did the third one? We got 1.9. We got negative 1.99. What are we going to get here? Maybe 1.999? And what would we get for our guess, right? What are we going to get here for our guess at the answer? Negative 1.999? How about negative 2 again? Won't that be it, right? These are still getting closer to negative 2. Why is this one negative 2 and the last one also negative 2? I don't know, just is. Right? So this is our guess again. Guess that instantaneous velocity is -2. Okay. So again, you have a few of those on the homework. You will, I don't know, they're not that much work. Once you get comfortable calculating these, it's good. If you have a pocket calculator, scientific calculator, you can calculate them faster than I am. Because you won't be switching over to the computer to do it over and over. Oops, close the homework. I am big dummy. All right. Now let's talk a little bit more about this conceptually. All right. So remember that these are slopes, okay? Remember, these instantaneous velocities, we're going to call them, or instantaneous rate of change, changes, because we're talking about plural. Instantaneous velocities or instantaneous rate of changes, they are slopes of tangent lines on a graph. So, for example, you know what a line with a positive slope looks like, right? What's a positive slope look like? On a graph, if a slope is positive, that means it goes up and to the right. And what's a negative slope look like? A negative slope is down and to the right, right? Now, something that's useful to know is, what is a zero slope? A zero slope is just a horizontal, okay? So you should know what positive, negative, and zero slope looks like on a graph. And what they're going to have you do to make sure you understand that on the homework is actually pretty simple. I'll show it to you, and then you'll know it, and then you'll never get it wrong, right? So here's what it looks like. So let's say I just draw a curve. There's a curve, right? And then I'm just going to say, like, let's call this -1, -2, -3. And I'm not going to use the grid over here because I want to get that point right there. So I'm just going to pretend that that's +3, and pick one more, 2, put that right there. All right, so I have 5 points here, right? Going to ask which of the 5 x values are places where the slope is positive. Right, and then we're going to do this negative and 0 as well. So all you're going to do is, we want positive slopes, and those are up and to the right. So where is it going up and to the right? How about here? Right? That's like this way. What about here? Yeah. Barely, but yeah. Right? Like it's about like that. It's kind of a shallow slope, but it is positive still because it's still up and to the right a little bit. Okay? So this is also a place where it's positive. Now what about the other points? I think this one's already negative. So not that one. So just these two that I highlighted, right? So that's it, just list them. How about x equals -3, x equals -2. All right, now I'll say where, I'm not going to say all that again, I'm just going to say where, or which, I should say, which x values, I'm just going to say show a negative slope. That's about the fastest way I can think of to say it. All right, so what about a negative slope? Negative slope is like this, down and to the right. So where does that happen? Well, I already said this one, right? I think this is a little bit down and to the right, kind of like that, right? That's down to the right. Where else? Here? Yeah. What about at 3? I don't think so, right? 3, it looks like at 3 the tangent line is like this. So that one is not negative. So if we're looking for a negative slope, just the two that I highlighted, which are x equals -1 and x equals +2. Now, where is the slope 0? Well, there's only one left, right? Just right here. So x equals 3. And that's where the slope is horizontal, right? Like this. Oops, not like that. Like this. And the tangent line here is horizontal. So that's what we're looking for. And those are pretty easy as long as you know what positive, negative, and zero slopes look like. All right. Let's see here. Okay, one more type of problem. All right, so the last one, it's I'll say it's a little bit tricky. It's not that tricky, but you know, maybe I'll need to show you how to do it, or you would be confused the first time you saw it. But yeah. So this isn't technically the last one because there's a few very closely related problems, but let's see here. So they'll give you a graph, and they'll put, you know, a curve actually on it. So I'm going to put some points on here. Okay. Perfect. Okay, not perfect. Okay, I can't do that. I should draw on the curve and then the points. But you can always just draw the points fatter, and then it's like you do it right. Okay. So let's say here that we have some points on here. Let's call them call this 1, 2, 3, and I guess that makes this 3.5 based on where it is. Just realized that I must have said 1 and written 2. Okay. So this would be at -1, and I'll call this one at -2. Okay, let's just, okay, good enough. Good enough. All right. Now, let's say I wanted to estimate the slope at 3. So I'm going to just erase that here. It's in the way. Was it like this? It was definitely not there, right? It was actually right here, wasn't it? Okay. Close enough. Okay, close enough. Sorry. Let's do this. I'm going to say estimate the slope of the tangent line. I don't know why I drew so many points on here either, by the way. Estimate the slope of the tangent line at x equals 3. All right? So how are you going to do that? You don't have a formula. You're not going to calculate anything. Well, I shouldn't say you're not going to calculate anything. You're going to calculate something. But you're going to estimate it. So where is x equals 3 on the graph? It's right here, right? Now what you're going to do is you're just going to draw the tangent line. So just draw the tangent line like that. Okay, and you should know what a tangent line looks like, so you can draw it pretty much okay. Now, then what you're going to do is you just have to, you drew the tangent line, and then you just need to figure out what slope is that you just drew. And it's not going to be a perfect answer that you're going to get. It's just going to be kind of your best guess here. So you're going to need some y values here. I didn't draw any y values on here, but if you look at the way I drew these x values, 2 boxes is 1, basically, right? So let's just say that this is 2, and this is 4, and this is 6. Okay? Now, here's what you would do. This is my recommendation for how to do it. Here's a point on the graph. What are the coordinates at that point? It looks like 3, 0, right? Now I have my tangent line drawn here. So my tangent line came up here and it looks like it intersected right there. Now what are the coordinates there? And you're not going to be able to do this perfect, but just guess. What are the coordinates there? X value is 0. What's the y value? Maybe 5.5? I don't know. 5.5? I'm guessing, right? Guess. Now once I have 2 points, I can find the slope. So slope is it's not really a different number. I said, what slope is that? Well, what slope is that? Y2 minus y1, x2 minus x1. That is, let's say 0 minus 5.5 over 3 minus 0. So it's like negative 5.5 over 3. So it is whatever that is, 5.5 over 3, negative. Negative 1.83. And that's just, an approximation of it. So there you go. Now, it doesn't have to be a point like the one that I drew that intersects the x-axis. It's just any point on there, okay? Any point on the curve. And, yeah. So the only last thing that I could ask about this would be something like this. So they will give you a graph. They'll put some points on it. Wow, this is really laggy. I drew a point like 5 minutes ago now. There it is. It turned into an eraser somehow. Undo. Alright. They'll give you several points on here, and then they'll say something like this. Where is slope equal to -1? Question mark. Okay? And you're not picking from every point, only the points that they list. Normally they give you more than they did though, right? Now, you're not doing a lot of work here. You're just basically doing what you did on the previous problem. Or actually you're not. You're not doing what you did on the previous problem. You're just using the same knowledge that you did on the previous problem. Like, what can you say about the slope right here at -1? Well, the tangent line's like this, right? Is that slope positive, negative, or 0? It's positive, right? And what about here at 2? That's horizontal, so what's the slope? 0. Now what about here at 4? Slope's like that. What kind of slope is that? Negative, right? So if I only have these 3 points to pick from, negative 1, 2, and 4, right? If I only have negative, if I only have x equals negative 1, x equals 2, x equals 4, that was actually 0 here, I just realized. If these are my x values here, which one has, that's not what I wanted to erase. That's still not what I wanted to erase. That's still not what I wanted to erase. Okay, I don't think I can erase it then. Okay, if these are the 3 points we have to pick, which is the one where the slope is negative 1? Well, it's got to be this one, right? It's the only one with the negative slope. Okay? That's the only negative slope. All right? Now, what if there was more than one negative slope? What if they also gave me like a point down here to choose from? Well, then you would have to decide which one was a slope of negative 1, right? And you'd have to draw in the tangent line here, and you'd have to draw the tangent line here, and you'd have to say, well, okay, this one is shallower than this one. Well, which one looks like it's a slope of negative 1? Slope of negative 1 is going to be like 1 over 1 up, right? So when there's boxes, remember that like, you know, let's see here. Oh man, this is so laggy right now. It's really hard to use. Remember that like a slope 1, I'm going to write positive 1 here. That means like 1 up, 1 over. 1 up, 1 over. Right? So when the slope is 1, it's basically, you know, 2 over 2 up, or 3 over 3 up. If you have a slope of 2, that means like from one point it's up 2 over 1 to get to the next point. So that's steeper. If you had a slope of 1/2, that would be up 1 over 2. Right? So you can tell not just positive or negative, you can tell relative magnitude, right? Like you can tell the difference between a slope of 2 and a slope of 1/2 pretty easy. I circled those, so it's going to come in whenever it stops lagging. No, it won't. There and there, right? You can tell the difference between those slopes and that slope, right? Just based on how steep it is. And that's really kind of the same thing we were doing in the previous problem, but we got a number in the previous problem. All right, well, that is that. So I'm going to stop the video here and post this for you guys.